All of you switch on your camera. Now, today we'll do JEE level exercises 1. Okay, JEE level exercises 1. Now, JEE level exercises 1, open. In that, start with the first question. And I have told you in the last class, there is a formula which you will need to solve the question. Okay, and that same formula will be applied here. So first you give it a shot, then try to get the answer. Then I will tell you what should be the answer. Let's start. Now look at me. What I have done is this. Okay. In the circuit, the charge on the 5 microfarad capacitor will be. They are asking what will be the charge on the 5 microfarad capacitor. Okay. Therefore, answer. Many of you are having the answer as B, which is the correct answer. This is the correct answer. So what I have done is I have taken an equivalent capacitance of 5 and 2 over here, which will be nothing but 7. Correct? Now, can I say the potential difference across this whole branch, okay, across this whole branch will be 6 volt. Do you agree? Because in parallel, potential remains constant. Therefore, potential in the lower branch is equal to potential in the middle branch is equal to potential in the upper branch. Therefore, can I say the potential across the branch V will be 6 volt, total V, correct? And this total V is split into V1 and V2, correct? Because this is 3 and this is 7. Therefore, can I say, if I look at that circuit, can I say 3 microfarad will get V1 and 7 microfarad might get V2 and the total voltage will be 6. This much is clear. Okay. That means the total voltage over here is 6 volt. Total voltage over here is 6 volt. The total voltage on this capacitor and the total voltage on this capacitor will be V1 and V2 because voltage in series adds up. Now, do I need V2? Correct, because I need voltage on the 5 microfarad or I need charge on the 5 microfarad. Therefore, can I say if I want to find V2, therefore, can I say the formula which I have told in the last class? What is V2? V2 is equal to V into C1 divided by C1 plus V2. In fact, this was the option which I told you. Please remember. Now tell me what will be the voltage across this. Tell me. What is V?
1.8.
6 into 3 divided by 3 plus 7. Therefore, can I say it is 9 by 5? Therefore, can I say it is 9 by 5? Easy. Now, 9 by 5 is the voltage across this. Voltage. Now I need charge. What is charge? Q equal to C into V. Therefore, answer is 9. Is it clear? Answer is 9, which is B, because we need the charge, not the potential. Does this question look familiar, similar? Solved it in the exam? Understood? It was based on the formula. I have just shown it again. Got it? Now you have to be very, very careful. If the potential was asked, answer would be 9 by 5 directly. If the potential was asked, answer would be 9 by 5 directly. Over here, there was the charge. Therefore, it is potential. Okay, that is Q equal to C into V, where C was given as 5 and V is 9 by 5. Therefore, answer is 9. Got it? All of you? Okay. Question number 2, take it as your homework 1. Question number 2, take it as your homework 1. Start with question number 3. Start with the answer. Question number 3. Okay, now look at question number 3. The equivalent capacity for the arrangement of capacitors as shown in the figure is, so this is A. Now I have capacitor over here and I have capacitor over here and I also have a capacitor over here and I have B. Now if you notice, this point and this point will be at the same potential. This point and this point will be at the same potential because same capacitance, same amount of flow. Therefore, this point and this point will be at the same potential. Therefore, there is no potential difference between this point and this point. If there is no potential difference, what happens? No current flows. And if that is the case, I can ignore this capacitor completely because it plays no role at all. Because the potential difference between the top part and the bottom part is the same. That means there is no potential difference. It is equal potential. Therefore, over here and over here, the potential is the same. Therefore, the potential difference is 0. Therefore, I can ignore it. Now, if I ignore that capacitance, can I say the two capacitors, that is this one and this one, are in parallel? And if two capacitors are in parallel, can I say the equivalent capacitance will be 2C because it becomes C plus C, it will become equal to 2C. Therefore, answer for question number 3 is B. Make a note. Most of you have given me the right answer who have answered. The people have given me the right answer. Sharvari, Sumitra, Malhar, Aniket. Okay. Others have either not given the answer or have given me the wrong answer. Question number 4, take it as your homework. Question number 4, take it as your next homework. Question number 6, start solving. Question number 6. The reason is the potential difference is 0 between the top part and the bottom part. If there is no potential difference, there is no current. Therefore, I can ignore that complete branch of the capacitor. It does not play any role in the circuit. Understood, Kennedy?
Yes, sir.
Tell me, what is the first thing that you will simplify? Tell me, what is the first thing that you will simplify?
4 and 4.
Which one?
4 and 4.
Okay, we'll take 4 and 4. We can do anyhow. Okay, if I take 4 and 4, tell me what will happen. 4 and 4 are in series. Now tell me, when two capacitors 4 and 4 are in series, what is the equivalent capacitance?
2.
2, because it will come 1 by 4 plus 1 by 4, 2 by 4, 2 by 4 is 1 by 2. Reciprocal of 1 by 2 is 2. Therefore, the answer that I will get is answer that I will get is 2. Now, can I say this 2 and this 2? See here, I'll put it with this. This 2 and this 2 and this 2 are in parallel. Okay, because just look at this. I can redraw this 2 like this. Therefore, all 3 are in parallel. Now tell me, these 2 are in series or these 2 are in parallel? Just think.
Parallel.
They are in parallel. I'll show you how it can be in parallel. I can redraw the circuit like this. Therefore, can I say the top branch 2, 2 and 2 are in parallel? Therefore, I will get 6. And the next one is 3 and 3 in parallel, which will again be 6. Therefore, 6 and 6. What will be my answer over here? In series.
3.
6 and 6 will be in series between these 2 points. Answer will be 3 microfarad. Therefore, answer for the 6th one will be C. Now, let me see how many of you have given me the right answer for this. Sharvari correct, Aniket correct, Sumitra correct. Very good. On the page, come to question number 9. Start. You just have to simplify each and every combination and tell me which combination will give you the desired result for question number 9. Start. Answer will be the first circuit itself. Check whether you're getting the answer from the first circuit itself for question number 9. Check.
Yes.
Getting it? All of you? Answer will be the first circuit itself. In this kind of questions, right, usually the answer will be option A or option B because it will not extend to other circuits. Usually when you solve the first circuit and the second circuit itself, you will get the right answer. That is how you will get the answer. Okay. Similarly, try to solve question number 11. Start. Similarly, try to solve question number 11. I have redrawn the circuit a little bit so that you can get the relevant.
Sir, your voice is cracking.
Yes, sir.
I have redrawn the circuit a little bit so that you can get the relevant answer. Can you hear me? Can you hear me now?
Yes, sir.
Yes.
I have redrawn the circuit so that it will help you a little bit. Try again with that. So if you look at the screen, just see, let me do something for you. If you look at the screen, 3 and 4 are in parallel. 3 and 4 are in parallel. So the equivalent capacitance between 3 and 4 will be 7. Therefore, answer over here will be 7. And 2 and 1 are in parallel. Therefore, 2 and 1 in parallel, answer will be 3. Therefore, over here, the answer. Therefore, please look at from there, first capacitor, second capacitor, capacitor, fourth, fifth, and the negative supply. That means all 5 capacitors, first capacitor, second, third, fourth, fifth, negative terminal. That means all 5 are in series. Now tell me what is the equivalent capacitance of this combination. 1 by CS is equal to 1 by 21 plus 1 by 7 plus 1 by 28 plus 1 by 3 plus 1 by 7. Tell me what will be the LCM first of all numbers. I think 84 will be the LCM. Correct. 84 will be the LCM. So tell me what will be 1 by CS. Check. 1 by 21 plus 1 by 7 plus 1 by 28 plus 1 by 7 plus 1 by 3. Are you getting it? 59 by 84. Or CS will be equal to 84 by 59. Or CS will be equal to 84 by 59. First come till here. Tell me if you're getting this answer. First come.
Yes. Yes.
Yes, sir.
Clear now? Voice is clear? Okay. Tell me, are you getting CS is equal to 84 by 59?
Yes.
Yes.
Now, question is not to find CS. What is the question? Check. What is the question? After the switch S is closed and steady state is attained, the potential difference in volt across the capacitors of the plate A. Now look at plate A. Where is plate A? Check. That is 7 microfarad. Correct? Plate A is 7 microfarad. Check. That is the plate A. Correct? Now tell me, how will you get that answer? I got the equivalent capacitance. Now tell me, in series, I got CS is equal to 84 by 59. Correct? Now tell me what is the total charge on each capacitor. What is the total charge on each capacitor? Look at the screen. Since all are in series, the total charge on each capacitor is CS into V. The total charge on each capacitor is CS into V. What is CS? CS is 84 by 59 into what is the voltage of the source? 59. Therefore, can I say the total voltage will be, or the total charge will be 84 microcoulomb? I got the total charge on each capacitance as 84 microcoulomb. Therefore, potential on plate A, V is equal to Q by capacitance of plate A. Now, what is the overall capacitance? 84. Overall charge, sorry. Overall charge is 84. And what is the capacitance of plate A? If you look at the diagram, capacitance of plate A is 7. Therefore, answer is 12. Check. They have not asked you the equivalent capacitance. Equivalent capacitance is required to find the total charge. From total charge, I can get the voltage across each terminal. Therefore, voltage across plate A is Q by CA, and that is equal to 84 by 7, which is equal to 12. Which is equal to 12. Is it clear? Question number 12, take it as homework 3. Question number 12, take it as your homework 3. Question number 14, start answering. Question number 14, start answering. I've made the diagram simpler for you. I've made the diagram simpler for you. Now, can I say the potential across the first capacitor? Please look at the screen. Potential across the first capacitor will be 6, and potential across the second capacitor, look at this. This whole is 10. This is 6. Therefore, the potential remaining between 10 and 6, can I say, will only be 4. This is your clue number 1. Therefore, potential across the first capacitor is 6 and potential across the second capacitor is 4. Because this whole is 10, out of that, this much is 6. Remaining is 4. And the first one is complete 6. That is given. Just check. Therefore, V1 will be 6. V2 will be 10. Minus 6 because I want the potential of only this much. That is the potential difference. Now, this is the first data you should get, 6 and 4. Now, what they are asking is, what is the energy stored in the capacitor C1 and C2? You have to use the formula half CV squared
Half
directly
CV
and
square.
tell me. What is it? Someone was saying something. My voice is still breaking.
No, sir. No.
No, sir.
Option is not C. That is the correction because most of you have answered C. Answer is something else. Now solve it and tell me what should be the answer. Answer will be D. Tell me if you're getting it now. Because now if I get V1 and V2, now you know C1 and C2. You know C, you know V. Then can you get energy respectively using the formula half CV square? Tell me if you're getting the answer as D.
Yes.
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Question number 16. Start.
Sir,
Hmm.
the 14th question, can you show how you got D?
We'll finish this, then I'll come back to 14. You want the calculation, right?
Yeah, I got the
Hmm.
first part, but want second part.
Okay, I will do it. We'll finish this and I'll go back to 14. I can redraw the circuit like this. Check the same circuit. I can redraw it like this so that you understand what is parallel and what is series and all that stuff. Now go ahead and start. Okay, I'm getting answers from few of you. Others try to give me the answer. Okay, now I can simplify this M. This will be C and this will be C in parallel. Therefore, I can write it as 2C. And this point I'll keep it as it is. This point I can keep it as C. Now again, these two are in parallel. I can keep that as 2C. And this is again C. This is the first step simplification where two parallel circuits are solved and I have got this answer.
Sir, can you show how it is 2C?
This is C and this is C. In parallel, they add up, therefore it will become 2C.
Okay,
And
got
over
it.
here also, this is C and this is C. In parallel, they add up, they be 2C. Clear?
Yes.
Now, 2C and C are in series. Tell me, if 2C and C are in series, what is the equivalent capacitance? What is 2C and C in series? Equivalent capacitance in series. Therefore,
2
can
by
I
3.
say answer is 2
2
by
by
3.
3.
3 by 2 is 1 by C. 2 by 3 will become C, not 3 by 2. 2 by 3, getting it? Therefore, can I replace this by 2 by 3? This whole thing, I can replace it by 2 by 3. Now, 2 by 3 and 1 are in again parallel, check. So what is 2 by 3 plus 1?
5 by 3.
5 by
5 by 3. Therefore, can I erase this? And can I write it as 5 by 3C? Can I erase this and write it is 5 by 3C? Correct? Therefore, 2C and 5 by 3C. Correct? Now, 2C and 5 by 3C. How do I do it? Now, they are in series. They are in series. So, simplify. Therefore, 1 by 2 plus 1 by 5 by 3. Start and give me the answer. You will
11
get
by
10.
10.
11 by 10 is 1 by C. Correct? 11 by 10
10 by
will
10
be
11.
by
1 by
11.
C.
A.
Therefore,
10 by
answer will be 10. 11 by 10 is correct, but that is 1 by C. You will get 10 by 11. That answer will be A. Okay, all of you. Okay, now 14th one I had to do it. So the formula for the 14th one, someone wanted it, I'll do it. It is half CV square. Correct? 14th one is half CV square. Now let
Yes.
me do the 14th question. So half CV square for the first one will be half into 2 into 6 square. Correct? because here 2 is there, here 6 is there. Therefore, half into 2 into 6 square will be 36. Therefore, the first answer is 36. Getting it, all of you? And the next one will be half into 3 into potential difference is 4 square. Half into 3 into 4 square. So can I say 4 square is 16 into 3 divided by 2. 2 ones are 2 eights are 8 threes are 24. Therefore, answer is 36 and 24. Tell me, are you getting it, all of you?
Sir,
36.
in question it is given 6 volts and 10 volts, no?
Exactly. That is what I showed you the diagram. This whole thing will be 10 volt. Look at the screen. In that, this is already 6. Therefore, how much will be left here?
Okay, got it.
10
Got it.
minus
Yes,
6
sir,
volt.
got it.
Okay.
Yes.
Twenty-two. Start. Question number. Twenty-two. This is the question. Now look at this. It's a very simple thing. If I keep my point B over here at one end, everyone look at the screen. If I keep my point B over here at one end, and if I keep my point A over here at the other end, therefore can I say, see here, these two will be in series compared to point B. I think I lost my screen sharing 1 minute.
No, sir, it's visible.
Yeah, it will go now. It's gone from this. Wait. Now look at this. If I keep my point B over here, I can say, one minute, I'll write with this only. I can say this. I can say this is my 2 microfarad. Even here it is my 2 microfarad. Over here it is 6 microfarad. Over here it is 3 microfarad. I have just redrawn between point B and point A. So point A, now if you look at this, this will be 2. Now, if you look at the comparison, this is point B, this is point A. Correct. Now, between point B, there is 2 microfarad. And there is again 6 microfarad. And here there is 2 and here there is 3. Now, isn't this equivalent circuit much more easier? Now, can anyone tell me how do you simplify this? Can I say this will become 4? Actually, right, I'll tell you one thing. If these two are in series, I told you last class also, if there is a point that comes in between, they are no longer in series. They are in series only if there is no interruption. If there is any node or if there is any junction, then there is an interruption. If not, series in parallel. That same logic we can use here also. That is from this equivalent circuit. Therefore, this 2 and this 2 in parallel will become 4, and 3 and 6 will become 9. This is my first clue. That means I'll get 4 and 9 in series. Now it's up to you. Start. Or if you don't want to draw the equivalent circuit, you should know that this will become parallel. This will also become parallel, and this will become series. Now start. Answer will come as B. If you're getting that, then the answer is correct. If you're getting any other answer, your answer is wrong. Answer has to be option B, B for Bombay. Getting the answer? Option B. Clear? Option B. So if you want to know the exact answer, this will become 4 and this will become 9. So 4 and 9 will go in series. 4 and 9 will go in series. Therefore, I will get 13 by 36. And the reciprocal will be 36 by 13, which is option B. Getting it, all of you? Turn the page. We have done a similar one, but give me the answer quickly. Give me the answer for question number 25. Start. Question number 25. Question number 25. One minute. Question number 25. Answer will be 3 identical capacitors are connected together differently for the same voltage to every combination. The one that stores maximum energy. Can I say it's a repeat question? We have done it at state level. Correct? And the answer was what? All 3 have to be in parallel. We have done the same question actually. The voltage is constant, energy is directly proportional to capacitance. And capacitance in parallel will give you maximum capacitance. Therefore, maximum capacitance will give you maximum energy. Therefore, answer is B. Got it? Now, at the end of today's class, I'm going to teach you one topic when more than one dielectric is inserted between the plates. When more than one dielectric is inserted between the plates. And once you finish doing that topic, you will be able to solve. Make a note of your next homework. Homework 4 is question number 27 and question number 28. Both are similar. One is in series, one is in parallel. I will do the topic at the end of our today's class. Based on that, you will be able to solve question number 27 and question number 28. Okay. How many homeworks are done? 5 homework are done. And question number 30 is your homework 6. Question number 30 is your homework 6. I'm having problem with screen sharing. Okay, no problem. I'll come back on this. Start with level 2, question number 31. Start with level 2, question number 31. In the meantime, let me come back on the question number 31. The plates of a parallel plate capacitor are charged with surface charge densities sigma 1 and sigma 2. The electric field inside the points. Answer does not matter on the question. Electric field between the 2 points of the capacitor will always be uniform and non-zero. Doesn't matter what the question is, what the surface charge density is. That is the definition of a capacitor. Therefore, answer has to be D. Always, whatever the condition given in the question, and it should be between the plates. That is inside the region the field is stored. Now the next question also, whatever the question does not matter, answer will be the same. That is question number 32. Question number 31, answer is D, standard answer. Similarly, try to give me the answer for question number 32. Similarly, try to give me the answer for question number 32. If you remember this formula that I have given you, check. E is equal to minus dV by dx. Remember this formula. Electric field is always the negative potential, negative slope of potential. Negative slope of potential is only one graph. Doesn't matter what the question is. You should know the relation between electric field and potential. I have written the formula on the screen. And you should also know that electric field is always the negative slope of the potential. Therefore, you should know which option will therefore match. Which option will therefore match the options. Take your time, read the question, read the options, and then we go to the next one. There is only one graph which matches the negative potential. That electric field is the negative potential, and that answer is B. That answer is B. B for Bombay. Therefore, if you look at question number 31 and 32, both are actually standard questions. They might change the question in a certain way. They might make some alterations, but the answer will not change. The logic doesn't change. Therefore, be very careful. The question can come in any form. Answer for the 31st one will be D itself, and answer for the 32nd one will be option B. Okay. Now, 33rd one is your next homework. 33rd one is your next homework. How many homeworks are done?
7.
3 more. Okay. Screen visible?
No, sir. No, sir.
Okay, I will come back. There's a lot of issues with this today. Okay, 36th one you start. I will come back on the screen. 36th one you start. Okay, now listen. 36th one. 1 minute. Okay, 36th one. A photographic flash unit consists of a xenon filled tube. It gives an average power. Therefore, power is given as 2000 watt and time is given as 0.04 second. And the capacitor is given as 40 microfarad. That means 40 into 10 power minus 6 farad. Now, what is the voltage? Now, can I say if power and time is given, can I say energy is given indirectly? What is energy? Power into time. Therefore, I know the formula for energy is half CV square. Now, instead of writing energy, can I write the formula as power into time itself? It is same because power into time is nothing but energy is equal to half CV square. Can I say in this formula, everything is known except V and only V is supposed to be found out. Therefore, can I say this is an indirect question of energy stored in the capacitor, where instead of energy, they have given power and time. So let us start. So power is 2 into 10 power 3 into time. 0.04, can I write it as 4 into 10 power minus 2? Just check whether I am right or wrong.
Yes.
4 into 10 power minus 2 is equal to half into 40 into 10 power minus 6 into V square. Now, I'll try to simplify it here itself. 2 ones are 2 20s are. Therefore, here I got 20 into 10 power minus 6 into V square. Now, 20 into 10 power minus 6 can be written as 2 into 10 power minus 5. 20 into 10 power minus 6 can be written as 2 into 10 power minus 5. 2 into 10 power minus 5, correct? 2 into 10 power minus 5 V square. Now, I'll erase the top part. So the left hand side will become 4 into 2, 8 into 10 power 3 minus 2 is only 1, correct? 3 into 10, 10 power 3 and 10 power minus 2 is 10 power 1. On the right hand side, I have 2 into 10 power minus 5 into V square. Is it clear? Now, actually from here itself, if you look at the options, you will get the right answer, but you can still continue. So tell me, if I continue, what will happen? So V square on one side. So it will be 8 into 10 divided by 2 into 10 power minus 5. So V square will be 2 ones are 2 fours are 8 into 10 power 6. Correct? 10 power minus 5 on top will become 10 power plus 5. 10 power plus 5 into 10 is 10 power 6. Now, if V square is 4 into 10 power 6, can I say V will be 2 into 10 power 3. Now V is 2 into 10 power 3, which is 2000. Is it clear? V is 2000 volt, which is the answer. Is it clear? Therefore,
Yes.
36th one answer will be B. 36th one answer will be B. Now, another simple question, turn the page. Start with question number 39. Start question number 39. Before you do 39, quickly tell me the answer for 40. We have done a similar question last class. First do 40, then do 39. First give me the answer for 40 and then give me the answer for 39. I told you that combination is not in series because there is a node in between. Last class also we have done similar. Now tell me the answer for 40. Correct. 40 will be correct. Sharvari correct. Sumitra correct. Devansh, Malhar, Sakshi, Yash, Riya, Aniket correct. Sakshi correct. Answer is B. Answer for the 40th question will be B, correct? Because I know that they are not in series. If not in series, they will have to be in parallel. And the parallel combination will be 3C. That is C plus C plus C, which will be 3C. Therefore, 40th one answer is B, which is clear. So all of you have got that. Now come to question number 39 and tell me if you can solve it quick. Question number 39. Okay. Now tell me, what can I simplify first?
8 and 8 are
Can
in
I say
series.
8 and 8 is 4 first? Can I say 8 and 8 is in series in this particular circuit? Therefore, can I take 8 and 8 over here? Look at this. I can take this as 4. Tell me, what else can you simplify?
6 and 12.
Which one?
6 and 12 are in series.
6 and 12 are in series. What is 6 and 12 in series combination?
12 by 3, that is 4.
6 and 12. Can I say that will also be 4? Therefore, can I erase this? And can I also write this as 4? Then what else can I do?
4 and 4 are in parallel.
4 and 4 are in parallel. 4 and 4 in parallel will give me answer as 8. Correct? 4 and 4 in parallel will give me answer as 8. Now,
8 and 8 are in series.
8 and 8 are in series. 8 and 8 in series, if I can erase, 8 and 8 in series will be 4. Now, this I'll just redraw it so that you understand it. Can I write it like this? Same way. Now, can I say 4 and 4 are in parallel? Again, can I say 4 and 4 are in parallel? Again, therefore, answer will be 8. Now, 8 and 8 are in series, answer is 4. 8 and 8 are in series, answer is 4 between A and B. Can I say that is the question? What is the question? Yes. What is the equivalent circuit itself? Therefore, answer is 4. Getting it, all of you? Now, I got many of you giving me the answer as A. Check where you have made the mistake and you're giving me the answer as A. It is not A. Answer has to be C. Answer has to be C, not A. And since many of you have given me the answer as A, you might have done one particular simplification which might be wrong, series and parallel. And whatever I have done, that is the only way to solve. There is no other way to solve this particular circuit. Other circuits I could have told you can start with any other way. This particular circuit can only be simplified in the way that I have shown. There is no other simplification possible. And in the same way it is possible. That is why you cannot have some other approach and get stuck. You should have the same approach. So please reply once in the message box. How many of you got the answer before I started solving? Got the same answer as 4. Just reply. Now can I get the right answer? Now can I say everyone can get the right answer and you can simplify? Clear?
Sir.
Next page, question number 51, take it as your homework. Next page, question number 51, take it as your homework. How many homework done?
8.
8. Okay. Take 55 as your homework. And take 48 as your homework. I wanted 10 homework. 48 as your homework. Okay. Written. Now, come to page number 32. Now come to page number 32, all of you. Come to page number 32. In that section 8.9.1, the entire section, take it as your homework for reading, nothing to write. Take it as your homework for reading. 8.9.1. Take it as your homework for reading. And what we have to do, right? Page number 32. Page number 32. Section 8.9.1. Okay. Now what we have to do, and that is very important, and I want you to write this in your notebook also, is page number 34. Page number 34. Page number 34. Some important cases of compound dielectrics. Page number 34. Some important cases of compound dielectrics. Now, this particular section is important because listen, if several dielectric medium is filled between the plates of a parallel plate in different ways as shown in the figure. Now look at the diagram 1. Can you see in this two dielectrics are filled K1 and K2 and see how they are filled. They are filled vertical strips. Okay. Now this combination, they are assuming it to be filled as series. Okay. Now if you look at the section down, the system can be assumed to be made up of two capacitors, C1 and C2, which are connected in series. Now, what will be C1? A K epsilon naught by D. But can I say distance is only half? Check the diagram. Therefore, can I say C1 will be A K epsilon naught by D by 2, but it will be K1. And C2 will be A K2 epsilon naught divided by D by 2. Therefore, capacitance in series 1 by C is equal to 1 by C1 plus 1 by C2. You will get the final answer. Therefore, in a problem, you can directly use this formula, or you can take C1, you can take C2. But the important thing is, if the strips are vertical, they are supposed to be connected next to each other. Therefore, it is considered a series combination. Therefore, I want you to write case 1. Draw the diagram, write what is C1, what is C2, what is C equivalent, and get the formula. There's no need to by heart the formula. If you know the formula, well and good, but you should be able to derive. And I have given you homework 3 and homework 4, or homework 4 and homework 5 with similar questions. Okay. So right now, just take this as your point number 1. Take this as your point number 1. Take this as your point number 1. Is it clear? Take this as your point number 1. And once you're done, please put a dot, then I'll take you to the next case. Clear? Now, look at case 2. Okay, just look at it, just on the page, and look at case 2. Everyone. Now, can I say we can look at it like horizontal strips? Just check between the two plates. They have filled as horizontal strips. In this case, listen to me. D will remain same, A will become A by 2. Now look at the previous question. In that, A was same, D became D by 2. Check. In this diagram, if you check, D will remain D itself, but my area will become A by 2 and A by 2. Now this kind of combination is called as parallel combination. Now if you look at C1 and if you look at C2, you will have A by 2 and A by 2. D will remain itself, and since they are in parallel, I have to add them. Did you understand the second case? Just check. Please remember, if area gets divided, it is parallel. If distance gets divided, it is series. Can you remember that keyword? If area gets divided, it is parallel. If distance gets divided, it is series. Or you can remember it as vertical combination and horizontal combination. Anyhow, you have to remember, but don't get the wrong answer, or don't put series formula in terms of parallel. Okay. Therefore, there are many ways to understand. So can you make a note of point 2? Just check. In this case, the two capacitors are in parallel. Instead of A, they have substituted A by 2, and D has been kept as D itself. And since they are in parallel, the capacitance adds up. That is C1 plus C2. Therefore, your answer will be, you don't need to by heart it. They're just showing it to you. You can do the same thing in the exam. Get C1, get C2. C1 and C2 you have to get. Then whether it is series or parallel, that is up to you. Got the case of hybrid? Now look at case 3. Case 3. Vertical, you can take it as series, but you can remember that when the distance is divided, then it is series. 1 minute. See the third combination. Now, in that, there are 3 cases. Just check. C1, C2, C3. There are 3 combinations. C1, C2, and C3. Check. C1, C2, and C3. Now, can I say C1 and C2 are in series because it is vertical or the distance is divided? That will be in parallel with C3. Now, this is just an example. You don't need to by heart it as a formula. In the exam, they might give you 2 series, 1 parallel, 2 parallel, 1 series. Always better to find out individual capacitance, C1, C2, C3. Then check whether C1 and C2 are connected in series. Then in parallel, use the formula. Because if you go to by heart the formula, final result, there are many cases to by heart. Instead of that, try to understand the logic. Now over here, case 3, don't write the case 3. What they have written, C1 and C2 are in series, while the combination is in parallel with C3. Check, you can understand it. Okay, and see what they have substituted. Tell me if you can understand what they have substituted. You don't need to remember it as a final result. Just tell me if you have understood the steps, what they have done. What is C1 value, what is C2 value, and what is C3 value. That's it. After that, it is equivalent is fine. Let me know if you have understood what is C1, what is C2, and what is C3. Let me know. Understood?
Yes, sir.
Please respond, all of you.
Yes, sir.
The main thing that you need to do for JEE mains, okay? For JEE mains is case 1 and case 2. That is the thing we need to do, case 1 and case 2. No, it should be K2, Aniket. It should be K2. Correct. Okay, now listen. Last problem, and with that we complete our capacitance. I'm not telling you to solve. I'm telling you to see the question and tell me if you have understood. You can solve it later. It's not a homework also. It is just for you to understand. See illustration 15. In fact, this kind of questions have now started coming in boards also. And MHT-CET, if you're answering, this is a very direct question. Read the question, read the data, read the answer. Substitution and solving, you can do it on your own. I'm not telling you to solve it right now. I'm telling you to see the question and let me know whether you have understood. See the question. A parallel plate capacitor is to be designed with the voltage rating of 1 kilovolt. Therefore, voltage rating is 1 kilovolt, which is same as 1000 volt, using a material of dielectric constant 3. Therefore, dielectric constant is given as 3 and dielectric strength is about 10 power 7 volt per meter. For safety, we would like the field to never exceed 10% of the dielectric strength. What is 10% of 10 power 7? You would never like to exceed it. Okay, see the answer. Okay, so we have got E, we have got V, and you know the distance V is equal to ED. Remember our few table, or V is equal to ER. From there, I will get the distance D. That is the logic. And then I have to directly use the formula for parallel plate capacitor, A K epsilon naught by D. That K is epsilon R in the answer. Don't get confused. Epsilon R is actually K. Therefore, A K epsilon naught by D. In this case, I have to find A. Everything else is given. Now tell me whether you have understood this kind of a problem. Tell me whether you have understood this kind of a
Understood. Yes, sir, understood.
check. Okay. Others. Okay. Okay. Take 1 more minute. Take 1 more minute and check. If you have understood, 1 more, not mandatory, but try and tell me if you have understood. Illustration 16. Illustration 16. Don't solve it, just let me know. Others who are stuck with 15, put your message. Why C is given in the question? Check. C is given in the question. Why did we substitute C as 50 into 10 power minus 12? Because it is given as pico. Just check. It is given in the question. Capacitor is given as 50 picofarad. And illustration 16. Start. Illustration 16. Read it and let me know. To restore the capacitance to its original value, that is why we are equating both. To restore the capacitance to the original value, that is why we are equating both. That is the logic. People were thinking why we are equating from 1 and 2, because they have told in the question we are restoring the capacitance to its original value. Check. Tell me yes or no, understood or not. Just reply. Illustration 16.
Understood, sir.
Understood.
Okay.
Yes.
Understood.
Illustration 17. Start. I'm telling you start because this we have already done as a part of our boards. Same question. That is why please realize this. We have done the same question. Illustration 7. Remember, while I was doing the module, the first first few classes. Same logic. Remember, we have done the similar question, or in fact, the same question. Again, don't solve it. Again, just check it out. These are the kinds of questions that come where distance and thickness has to be asked. Tell me if you have understood.
Understood.
Yes.
Yes.
Done a similar one, correct? But in the first classes, we have done the similar question for. So illustration 15, 16, 17, these now are actually MHT-CET type of questions, okay? They used to be asked in JEE some time back, now not that much, but nevertheless, keep revising. Any doubt in today's class? Let me know.
Okay.
No, sir.
Okay. Next chapter that we are going to start, I'll start in the next class, and that chapter will be current electricity 1. Everyone has the module of current electricity 1.
Yes, sir.
My request to all of you, or my homework for all of you, in fact, is 11th standard current electricity, please revise that we have done together. 11th standard current electricity, what we have done, resistors in series, resistors in parallel, color code of resistance, cells in series, cells in parallel, resistivity formula we have done, EMF of a cell we have done, temperature coefficient of resistance we have done. 11th standard current electricity, what and all we have done. Please go through that. That will help you in current electricity 1. I'll repeat the topics. Resistance in series, resistance in parallel, cells in series, cells in parallel, color code of resistance, temperature coefficient of resistance, and resistivity. These topics. Is it clear?
Yes.
Okay. Okay. So I will
Yes.
see you in the next class, and that is the homework. I hope today's homework is also clear. And with that, we are done with capacitance. Now be ready with current electricity. Current electricity will be a huge topic because we'll have current electricity 1 and current electricity 2. Okay, so please don't bunk any class in between for current electricity. Okay. So thank you all of you. I will continue in the
Bye, sir.
Thank you.
Thank you, sir. Bye.
Thank you. Bye.